The Challenger tragedy, which occurred on January 28, 1986, was not merely a technical accident. It was an event that became synonymous with human and systemic failures within one of the world's most respected institutions, NASA. The Space Shuttle Challenger disintegrated just 73 seconds after launch, killing all 7 crew members, including Professor Krista McAuliffe, the first civilian and professor chosen to travel to space. The disaster generated a shockwave that reverberated throughout the world, not only because of the tragic loss of human lives, but also because of the breach of public trust in one of humanity's greatest achievements, space exploration. The cause of the accident was attributed to a failure in the O-rings, sealing rings used in the joints of the solid-fuel rocket, which failed during launch on an exceptionally cold morning. But what many people don't know is that the Challenger tragedy was far more complex than a simple technical defect. It was a result of a series of human, cultural, and organizational failures, and at the center of this story, one man stood out: Roger Boysley. Roger Boysley was an engineer at Morton Thiokol, the company contracted by NASA to manufacture the Space Shuttle rockets, including the solid-fuel engines. Boysley was in a unique position as someone who had a deep understanding of the systems involved in the launch and, more importantly, of the O-ring failures that could compromise the entire process. In the weeks leading up to the launch, Boysley and other engineers at Morton Thiokol began to realize that the weather conditions, intense cold, posed a significant risk to the integrity of the O-rings. When these sealing rings failed, fuel could leak out of the engines, creating a huge safety threat. Boysley knew that NASA was in a race against time to meet deadlines and impress the public with the success of the space program. He and his colleagues were also aware that if the launch were authorized under those conditions, the risk of catastrophic failure was immense. More importantly, Boysley was convinced that he had an ethical and professional responsibility to alert both NASA and his superiors at Morton Thiokol about the imminent risks. When Boysley tried to raise a red flag about the O-ring problem, he faced resistance at all levels. His concern was not taken seriously by his superiors, and worse still, the pressure perceived with the mission was immense. He and his colleagues argued based on technical data and a deep sense of responsibility, but NASA, in an effort to maintain the space program schedule, decided to proceed with the launch. At that moment, NASA was under intense pressure. The space program was at a critical stage, and Challenger was seen as an opportunity to demonstrate the reliability of the space shuttle and its impact on space exploration. Furthermore, NASA was facing strong international competition, especially from the Soviet Union, which still maintained a significant presence in space. In this scenario, political and public pressure for the mission's success added to the decision to proceed with the launch, despite warnings from Boysley and other engineers at Morton Thiokol. This combination of factors, negligence regarding safety, pressure for quick results, and a failure in the communication process, resulted in a tragedy that many would say could have been avoided. The Space Shuttle Challenger was launched in extremely cold conditions, and shortly after liftoff, the O-rings failed. Fuel leaked, and within seconds, the spacecraft exploded in midair. 7 lives were lost. Commander Francis R., Scobie pilot Michael J., Smith mission specialist Ronald McNair, Ellison Onizuka, and Judith Resnick, as well as Krista McAuliffe, who was aboard as part of the Teacher in Space program, and her assistant, Gregory Jarvis. The mission and the loss of life marked history and altered the course of space exploration. Although the disaster has been widely attributed to O-ring failures and a lack of consideration for weather conditions, the real tragedy was that, before the explosion, several people had warned of the risks. Among these people was Roger Boysley, a man who, though unheard before the accident, became one of the greatest advocates for ethics in engineering after the tragedy. He not only warned about the technical problems that could lead to failure, but also had to face the reality that his fight for greater accountability at NASA and Morton Thiokol had been in vain. In this script, we will explore how a single man, Roger Boysley, and his silent struggle to avert the Challenger tragedy became a reflection of a larger systemic failure within highly complex organizations like NASA. We will discuss the historical and technological context that shaped the events of that fateful day, the cultural failures that contributed to the disaster, and, most importantly, how Boysley became a symbol of ethical resistance and professional responsibility in the face of corporate negligence. We will explore how his courage and warning about the risk was stifled by an organizational culture that, up to that point, had prioritized quick results over the safety of astronauts and the integrity of the space mission. Throughout this narrative, we will see how the Challenger disaster was not an isolated failure, but a reflection of a corporate culture that still puts human lives at risk in the name of short-term goals. Roger Boisterly, a man who only wanted to save lives and protect the astronauts, became the protagonist of a story in which ethics and morality were tested to the limit in a situation where survival itself depended on someone's courage to say no. The Challenger disaster reminds us that, however advanced the technology may be, when humanity loses itself in the pursuit of prestige or institutional pressure, lives can be put at risk. The United States space program, initiated in the 1950s and 1960s, represented not only a scientific achievement, but also a showcase of the nation's power and technological superiority. Competition with the Soviet Union, in the context of the Cold War, was one of the main drivers for the advancement of space exploration. The culmination of this race occurred in 1969 with the arrival of man on the Moon, when the Apollo 11 mission, commanded by Neil Armstrong, made history by placing the first human being on the lunar surface. This feat consolidated NASA as one of the world's leading research and innovation institutions. However, after the success of the Apollo missions, NASA faced a new challenge: how to maintain public interest and justify spending on space exploration in a context where the Cold War seemed to be entering a phase of détente. In the 1970s, funding for new space projects began to decrease, and NASA sought a way to make space missions more economical and frequent. The answer came with the creation of the Space Shuttle program, a project aimed at developing a reusable transportation system for space. The Space Shuttle was designed to be a revolutionary solution, capable of transporting astronauts and cargo into space, returning to Earth, and being reused in multiple missions. This idea of reuse was based on the growing demand for reduced costs and maximizing the use of each launch. The Space Shuttle, as the Space Shuttle became known, was announced with great enthusiasm as a new era of space exploration. It would be launched repeatedly, transporting satellites, cargo to the International Space Station, ISS, and even civilian astronauts. The Challenger was the second space shuttle to be launched and had a symbolic mission of high value for NASA. Its launch was scheduled for January 28, 1986, after several launch attempts that had been delayed due to technical and weather issues. The Space Shuttle was designed to be one of NASA's greatest triumphs in the early 1980s, symbolizing the continuity of the space program and the promise of regular and safe transportation to space. Furthermore, Challenger was chosen as the mission that would launch, for the first time, a civilian into space. Teacher Krista McAuliffe. McAuliffe was selected as part of NASA's Teacher in Space program, an initiative aimed at bringing the public closer to space exploration. She was a passionate educator, and her participation in the Challenger mission was a way to show the nation that space was not reserved only for career astronauts, but also for those who, like McAuliffe, were committed to education and the advancement of knowledge. She would thus become a symbol of the accessibility of space exploration. NASA saw in the program an opportunity to engage the public in a more direct and emotional way, and McAuliffe's figure brought great visibility and popular appeal to the launch. The Challenger mission was, therefore, a major gamble for NASA. Not only was it a milestone in the inclusion of civilians in space, but also served as a demonstration of the safety and viability of the Space Shuttle, especially after the success of the first shuttle, Columbia. However, while NASA was committed to ensuring the program was a visible success, there were serious technical issues that were being ignored or minimized. Throughout 1985 and into early 1986, NASA faced increasing difficulties in maintaining the Space Shuttle launch schedule. The time between each launch was short, and the Space Shuttle needed constant checks and maintenance. The program, although innovative, was being run under increasing pressure to achieve regular and successful launches. Engineers at Morton Thiokol, the contractor to supply the solid-fuel rockets, began raising questions about the integrity of the Space Shuttle components, especially regarding the O-rings in the rockets. O-rings were critical elements in ensuring that solid-fuel engines functioned without leaks. Any failure in the O-rings could have disastrous consequences, and this was widely known within the engineering community. Boisterly, who was directly involved in overseeing components at Morton Thiokol, had already detected signs that the O-rings were not functioning correctly, especially under conditions of intense cold, such as those predicted for the day of the Challenger launch. NASA, however, was extremely anxious to maintain its schedule and ensure that the launch occurred within the stipulated time, so that the Space Shuttle program would be successful and its credibility maintained. The Challenger launch was being treated as a showcase of success for the American public and the world. The pressure perceived with the launch was immense, and despite the concerns of Boysley and other engineers, the mission went ahead. The race to space that motivated the start of the Space Shuttle program was replaced by a race for visible success. NASA, with its reputation at stake, could not afford to postpone the launch again. The issue of safety and the real risk of a catastrophic failure were seen as secondary to the pressure of presenting itself to the world as an undisputed leader in space exploration. It was this mentality that helped create the scenario for the disaster. On January 28, 1986, the Challenger took off, and in just 73 seconds, the mission turned into a nightmare. The failure of the O-rings led to a catastrophic explosion. The mission was aborted, 7 lives were lost, and the dream of an accessible and safe space program suffered a devastating blow. The Challenger mission and its subsequent failure marked a turning point in the history of space exploration. For NASA, it was a moment of introspection and reassessment of its organizational culture. For Roger Boysley, the tragedy was a culmination of a personal and professional battle he had waged, trying to warn authorities about the impending danger. He became a symbol of an ignored warning, a man who knew something was wrong but couldn't prevent the disaster. But at the same time, he also became a champion of professional ethics and accountability in high-risk situations, helping to shape the future of NASA operations. Roger Boysley, the engineer whose whistleblowing would become a pivotal point in the Challenger disaster, wasn't a widely recognized name before that fateful day, but his role in the tragedy's history is irreplaceable. He became a symbol of the fight for professional ethics within a corporate culture that, unfortunately, prioritized deadlines and objectives over human safety. Boysley wasn't just an engineer. He was someone deeply committed to his moral, ethical, and professional responsibility. He had a clear vision of what was at stake when he raised a red flag about the O-ring risks, and later, about the decision proceed with the Challenger launch. Born and raised in the United States, Boysley grew up with a strong emphasis on values of integrity and responsibility. Although his name wasn't famous, he possessed extensive technical training. A trained engineer, Boysley worked for years in the field of aeronautics and rocket systems development. He was hired by Morton Thiokol, an engineering firm that had a contract with NASA to supply essential components for the Space Shuttle rocket, such as the solid fuel engines and the rocket capsules that propelled the spacecraft. In his work at Morton Thiokol, Boysley was part of a team responsible for the analysis and safety of O-rings, vital components for the operation of rockets. He quickly understood that O-rings were the most vulnerable points in rockets, being the first line of defense against catastrophic failures. The function of the O-rings was to prevent hot gases from the engine from leaking through the rocket joints, which could result in an explosion. However, Boysley realized that, under extremely cold conditions, such as those predicted for the Challenger launch, the O-rings could become fragile and fail. His understanding of the gravity of this risk made him one of the few to warn of the possibility of an imminent disaster. However, what distinguishes Boysley from other engineering professionals is that he did not remain silent in the face of risk. He knew that astronauts' lives were at stake, and that the project he was helping to develop was, in some way, a reflection of the promises made to the public and society. By the mid-1980s, Boysley was already deeply concerned about the technical problems with the rockets and how NASA and its contractors were handling safety issues. Morton Thiokol, the contractor responsible for the engines, was aware of the defects, but the pressure to maintain the launch schedule was mounting daily. Boysley repeatedly tried to warn his superiors about the risks of the O-rings and the technical problems associated with extreme cold, but he was ignored. For him, these issues were not merely technical. They were a matter of ethics. Boysley felt that the profession demanded that he be honest and transparent with his colleagues and superiors, especially when human lives were at stake. He knew that the Challenger launch, scheduled for January 28, 1986, will be a landmark for NASA and the world. However, as launch day approached, the weather in Florida was exceptionally cold. The cold, in turn, would affect the integrity of the O-rings, which would become rigid and unable to provide a proper seal. Boisterly and his team were convinced that if the launch were authorized under such conditions, there was a high chance of catastrophic failure. With the pressure mounting for Challenger takeoff, Boisterly had no choice but to become a tireless advocate for safety. He and his colleagues at Morton Thiokol developed a set of arguments based on technical data, attempting to convince their superiors and NASA that the launch should be postponed. Boisterly, in his defense, believed there was a moral responsibility to prevent tragedy, regardless of how high the cost of his career or his company. He knew that what was at stake was not just a rocket, but the lives of the astronauts on board and, more broadly, the reputation of NASA and the United States space program. During the famous meeting of January 27, 1986, just one day before launch, Boisterly and other engineers at Morton Thiokol were pressured by company executives not to question the safety of the launch. Boisterly, in his position, became one of the most vocal advocates for safety, but despite his efforts to delay the launch, the decision was made. Challenger would proceed as planned. However, his struggle was not in vain. Although the launch occurred, Boisterly had a lasting impact on the investigations that followed the disaster. After the tragedy, he became one of the leading whistleblowers of the incident, sharing his experience with investigators from the Rogers Commission, created to investigate the causes of the explosion. Boisterly revealed how his concerns and those of his colleagues were ignored, and his courage in speaking about what he knew helped to clarify the true cause of the accident: the failure of the O-rings. The story of Boisterly is not limited to the Challenger disaster. It is also an example of courage and integrity within a system that was about to compromise human lives in the name of efficiency and deadlines. His determination to do what was right, even when no one wanted to listen, is what made him a true hero. His action in not allowing the truth to be covered up set a precedent for the engineering industry and for future generations of professionals, showing the importance of maintaining the highest ethical standards, especially in high-risk situations. After the disaster, Boisterly became an active advocate for work ethics and safety in engineering projects. He became a critical voice on how corporate culture and institutional pressure can often disregard technical warnings and put human lives at risk. In his lectures and interventions, Boisterly emphasized that the true responsibility of an engineer lies not only in meeting deadlines or following orders, but in ensuring that the work performed is aligned with the highest standards of safety and ethics. To understand the magnitude of the Challenger disaster and the central role that O-rings played in that tragic event, it is necessary to explore not only the technical workings of these components, but also the conditions that led to their failure and the resulting accident. O-rings were critical components in the Space Shuttle solid-fuel rockets. Their function was relatively simple but vital: to ensure an airtight seal of the rocket engine joints, preventing the hot gases generated by the combustion of fuel from escaping, which could result in a catastrophic explosion. In the case of the Challenger, the failure of an O-ring in one of the rocket joints was key to the tragedy. The Challenger rockets were powered by solid-fuel engines, which were a major component of the launch vehicle. Each engine was composed of several parts, including segments with joints that were sealed with rubber rings, the O-rings. These gaskets, located at the joints between the engine segments, were designed to prevent fuel from leaking while the engine was firing and burning fuel to produce propulsion. The design of the O-ring seemed to be a simple technical solution, but at the same time critical to the success of the mission. They were, in essence, the barriers that prevented fuel from escaping into dangerous areas, such as the cavities in the rocket structure. Meanwhile, the O-rings were extremely sensitive to temperature variations. Under normal conditions, where the launch environment was moderately warm, the material of the sealing rings functioned adequately. However, if the launch occurred on a cold day, as happened on January 28, 1986, the O-rings could become brittle and less effective. The extreme cold impaired the elasticity of the material, making the rings less efficient at sealing the joints and allowing hot gases from the rocket to leak into unforeseen areas, with the potential to cause a catastrophic structural failure. The day of the Challenger launch was marked by unusual weather conditions for Florida, with temperatures well below what was expected for the month of January. The forecast indicated temperatures of approximately minus 1 degree Celsius 30 degrees Fahrenheit, which were much lower than normal for the location. This extremely low temperature was the main concern of the engineers at Morton Thiokol, the company responsible for the solid-fuel rockets. Boysterly and his engineering colleagues knew that the weather conditions could compromise the functionality of the O-rings. What they feared, and what was later confirmed as the cause of the accident, was that the O-ring would not be able to maintain a proper seal due to the cold, allowing hot gases to escape and compromise the rocket structure. Boysterly's warning. Roger Boysterly and other engineers at Morton Thiokol began to observe a potential failure in the O-rings after tests conducted at temperatures lower than typical launch conditions. When the tests were conducted, the O-rings did not behave as expected. The rings failed to completely seal the joints, which would result in fuel leakage. Boysterly realized that the O-ring failure was not a simple technical flaw, but a concrete threat to the safety of the astronauts aboard the Challenger. Boysterly, with the experience and knowledge accumulated over years of work in the space engineering sector, was extremely concerned about the implications of this problem. He could not ignore the seriousness of the risk, and his concerns intensified when he discovered that NASA was planning to proceed with the launch of the Space Shuttle, even in the face of the technical risks he had identified. Boysterly and his colleagues at Morton Thiokol conducted a detailed analysis of the effects of extreme cold on the O-rings and how this could affect the rocket's performance. They concluded that the O-rings might not be able to provide the necessary seal, which would pave the way for a failure that could destroy the Challenger. NASA, however, was pushing for the launch to happen at all costs. Challenger was a milestone for the space agency and the Space Shuttle program, with a Teacher in Space program, which included teacher Krista McAuliffe, attracting public and media attention. NASA was determined to carry out the launch and show the world the agency's confidence in the safety and reliability of the Space Shuttle. The launch was seen as a symbol of progress, and the institutional pressures for it to happen were massive. Corporate negligence and pressure to launch. Boysterly and his colleagues at Morton Thiokol were not only concerned with the technical problem itself, but with the pressure being applied to NASA to meet its agenda. The decision-making process within NASA and at Morton Thiokol was steeped in a corporate culture that prioritized mission success and schedule adherence over the safety of astronauts and crew. Boysterly felt completely powerless in the face of this pressure. He didn't want to be part of a system that ignored such serious warnings, and for him, moral responsibility was more important than meeting deadlines or expectations. At the crucial meeting held on January 27, 1986, just one day before launch, Boysterly was once again confronted by Morton Thiokol management and NASA executives. He and his colleagues were convinced that the launch should not take place under predicted weather conditions. Boysterly tried once again to convince his superiors to postpone the launch, presenting technical evidence and detailed explanations of the risks involved. However, in a move reflecting institutional pressure and the desire to proceed with the mission, NASA and Morton Thiokol executives decided to proceed with the launch. This conflict between safety and the pressure to proceed with the launch was undoubtedly one of the biggest mistakes NASA ever made. Boysterly, who had dedicated his career to space engineering, felt distressed at not being heard. What he feared was not just a technical failure, but the human risk that was being ignored by everyone involved. He knew that if the launch occurred, tragedy would be a matter of time. The catastrophic failure. On January 28, 1986, the Challenger was launched under extremely cold conditions. Just 73 seconds after liftoff, the worst nightmare came true. The O-ring failed. Fuel leaked and a devastating explosion followed, destroying the spacecraft and killing all 7 astronauts on board. The O-ring failure was not an isolated or technical error. It was a consequence of a series of wrong choices, negligence, and, above all, an institutional culture that prioritized expectations of mission success over the actual safety of the astronauts. Subsequent analysis of the accident revealed how the O-ring failure was amplified by adverse environmental conditions and how the pressure to maintain the launch schedule contributed to the disaster. The Challenger accident is a reminder that when technical issues are neglected in favor of objectives and deadlines, the consequences can be devastating. For Roger Boysterly, the Challenger disaster was not just a failure of a technical component, but the failure of a system that ignored warnings and disregarded obvious risks. Boysterly, who had tried to prevent the tragedy, became one of the greatest advocates for ethics and safety in the engineering industries, and his story continues to inspire professionals worldwide to prioritize safety and moral responsibility. The Challenger was launched under immense institutional and public pressure, but behind that decision was a clear warning that the risks were high, a warning that was ignored by those responsible. The negligence that led to the tragedy was not only due to a lack of rigorous technical analysis, but also to systemic failure to heed the warnings of an engineer who was concerned not only with the schedule or the success of the mission, but with the lives of the astronauts on board. Roger Boysterly, the engineer who tried to warn NASA and his superiors at Morton Thiokol about the risks posed by the low temperatures, was not alone in his concerns. He shared his findings with his colleagues, who, like him, were increasingly apprehensive about the launch conditions. Boysterly knew that NASA was eager to continue with its launch schedule, especially with Krista McAuliffe on board, but he believed that this could not override mission safety and the integrity of human lives. With extreme cold predicted for January 28, 1986, Boysterly and his fellow engineers at Morton Thiokol knew that the O-ring, a crucial seal for solid-fuel rockets, might not function properly. Although NASA was already aware of the problem, the gravity of the situation had not been given due attention. Boysterly had followed O-ring failures in previous tests and knew that, in sub-zero temperatures, the material used in the rings could become more rigid, failing in its sealing function. He also had the technical expertise to understand that O-ring failure was not just a minor problem, but a deadly risk. Boysterly's real dilemma began when he unsuccessfully tried to convince his superiors to postpone the launch. On the morning of January 27, 1986, he attended a crucial meeting with Morton Thiokol executives and NASA representatives. Boysterly and other engineers of the company insisted that the launch be postponed, as the weather conditions predicted for the following day represented an unacceptable risk. The technical argument was based on solid data demonstrating that, under such cold conditions, the O-rings could fail. Boysterly and his colleagues explained that if the launch occurred in such low temperatures, the risk of engine failure would be inevitable. However, the response Boysterly received was one of complete disregard. The directors of Morton Thiokol, who were under immense pressure from NASA, did not want to miss a launch, especially at a time of such high public visibility. NASA was trying to regain public trust after the failure of several previous missions, and the Challenger launch with Krista McAuliffe aboard was seen as a unique opportunity to publicize the space program. NASA's response was clear. They could not allow another postponement. The pressure to launch that day was overwhelming, and it was enough for the Morton Thiokol executives to give up. With the decision made, Boysterly knew what would come next. He was no longer just concerned about the consequences for the mission, but about the lives of the astronauts aboard the Space Shuttle. The decision to proceed with the launch, despite all the warnings, represented a tragic failure of NASA's safety system, as well as clear evidence of how institutional pressure and organizational interests can lead to catastrophic decisions. Boysterly had no doubt that the risk would be fatal. The decision made by NASA and the Morton Thiokol executives was based on a critical failure judgment, which ignored the science and the recommendations of their own engineers. Boysterly did not give up, however. After the disaster, he became one of the biggest whistleblowers of the accident. During the subsequent investigations, Boysterly detailed everything that had happened in the weeks and days leading up to the launch. He explained how his warnings had been systematically ignored and how institutional pressure and misguided decisions had led to the astronauts' deaths. Boysterly knew he had done everything in his power to prevent the tragedy, but at the same time, he was deeply aware that the system's failures were not his fault. They were the result of an organizational culture that was not prepared to take risk warning seriously. What Boysterly faced was a combination of corporate pressure, institutional ignorance, and a culture of compliance that prioritized quick results over safety and technical judgment. The warning from Boysterly and his technical team was an attempt to change the course of history, but the reality was that the system was at a tipping point, and the decision to proceed was made without considering the well-documented warnings and risks. The culture of ignorance and conformity. When Morton Thiokol engineers raised their concerns about the O-ring failure, what was really at stake was not just the technology, but the institutional culture within NASA and its suppliers. NASA, as a highly prestigious public institution, was under continuous pressure to demonstrate that the space program was functioning efficiently and safely. This pressure often undermined critical analysis and the ability of engineers to point out obvious flaws without suffering reprisals or being ignored. The culture of conformity, where the decision to proceed with the launch was made ignoring technical concerns, reflects a deeper organizational failure. Boystrely, who firmly believed in his ethical and technical responsibility, found himself in a position where his evidence-based words were not considered sufficiently important to prevent the decision. This often occurs in organizations that are under pressure to achieve results and prioritize business continuity over rigorous risk assessment. The Challenger tragedy was not just an isolated event of technical failure. It revealed a systemic failure in how high-responsibility institutions, such as NASA, handle warnings from their own professionals when those warnings do not coincide with external interests and pressures. The lack of action in the face of clear technical warnings and the pressure to achieve results at any cost are factors that, together, help transform a space mission into a national disaster. Boystrely's legacy. After the disaster, Roger Boystrely became an active advocate for professional ethics and safety in engineering projects, exposing the failure of NASA and its suppliers to comply with standards that should have been the norm. Boystrely did not remain silent after the tragedy. He extensively shared his experience with the investigations, denouncing what he saw as organizational negligence and incompetence. His courage in denouncing the failures and the disregard for engineers' warnings helped reveal the true cause of the disaster, as well as highlighting the importance of listening to the voice of technical professionals before making decisions with such serious implications. Boystrely's work, both before and after the accident, brought to light the need for cultural changes within large engineering organizations. He became an example of how ethical responsibility and professional honesty are essential to ensuring safety in high-risk situations. His personal and professional struggle led to awareness of systemic failures within NASA and other large companies, which often prioritize public success and results over careful risk analysis. The Challenger disaster was not just a technical failure or a poor choice of launch date. It was also a reflection of a corporate culture that prevailed at the time within NASA and its contractors, such as Morton Thiokol. The pressure to maintain a tight schedule, the incentives to achieve success at any cost, and the lack of a structure that favored open communication and listening to technical concerns created an environment where judgment and safety were relegated to the background. In the context of the 1980s, NASA was under immense pressure to demonstrate that the Space Shuttle program was successful and capable of conducting regular launches at a reduced cost compared to previous space programs. The first Space Shuttle mission, Columbia, had been a success, and there were high expectations for Challenger, especially with the presence of Krista McAuliffe, a civilian teacher, on the mission. The Teacher in Space project aimed not only to promote education, but also to restore public confidence in NASA, which had faced financial and technical challenges after the end of the Apollo program. The pressure to ensure the mission went ahead didn't just come from within NASA. High levels of public visibility, government pressure, and the desire to meet launch targets placed an enormous burden on the agency's engineers and executives. The Space Shuttle launch schedule was geared towards demonstrating the efficiency of the new space transportation system, and delaying the Challenger launch once again would mean not only a delay, but a blow to NASA's credibility and a potential reduction in federal funding. This pressure was internalized within NASA and its contractors, such as Morton Thiokol. Executives at Morton Thiokol, who manufactured the solid fuel engines, were aware of the O-ring failure and the potentially dangerous weather conditions for the launch. However, the pressure to get the Challenger off the ground was intense, and Morton Thiokol engineers were forced to comply with NASA's demands despite the obvious technical risks. The corporate culture within NASA was undoubtedly one of the main contributing factors to the tragedy. Instead of a collaborative approach that encouraged technical and ethical warnings from engineers, the institution operated with a hierarchical mindset where concerns were often subordinated to institutional objectives. When NASA prioritized the schedule over safety, the Challenger accident became a tragic inevitability. Boystrely, the engineer who tried to alert NASA authorities to the risk, became an example of how organizational pressure systems can silence technical and critical voices, resulting in disastrous decisions. After the disaster, reports and investigations showed a lack of efficient communication between the NASA teams, Morton Thiokol, and the engineers responsible for the launch systems. Instead of prioritizing technical rigor and adherence to safety standards, NASA was committed to meeting launch goals and ensuring mission success. This culture of compliance, where employees were encouraged to follow orders and prioritize the mission over safety, directly contributed to the tragedy. Furthermore, NASA's organizational structure, which involved multiple layers of hierarchy, created a scenario where vital information, such as Boysley's concerns about the O-rings, did not reach decision-makers effectively. Boysley, being just an engineer at Morton Thiokol, was limited by the hierarchical culture and a lack of adequate channels for his concerns to be taken seriously by NASA's top executives. The cultural negligence within NASA, then, was not just a matter of technical failures. It was a systemic failure of values. The relentless pursuit of perfection and success at any cost weakened the organization's ability to make informed and responsible decisions. This failure in strategic and organizational decisions became one of the biggest obstacles to ensuring the safety of the astronauts aboard the Challenger. The Challenger disaster was not just a technical accident. It was also a reflection of profound failure in the corporate culture of NASA and the contracted companies, such as Morton Thiokol, responsible for the essential components of the Space Shuttle. What happened on January 28, 1986, when the Space Shuttle Challenger disintegrated 73 seconds after launch, was not just a mechanical failure, but a combination of human decisions, institutional pressures, and organizational culture that failed to prioritize safety above all else. NASA, like any large organization, was under immense pressure to demonstrate rapid and successful results. Following the initial success of the Apollo program, the United States Space Agency was committed to ensuring that the Space Shuttle program was a successful, repeatable, and economically viable operation. The idea behind the Space Shuttle was revolutionary: reusable vehicles that could reduce launch costs over time while maintaining a higher mission frequency. To maximize its reusability and reduce costs, the program would need frequent launches, meaning that technical failures and delays needed to be avoided at all costs. However, in an organization like NASA, the pressures to maintain this launch schedule were becoming increasingly intense. The Challenger mission, carrying Krista McAuliffe, a public school teacher who had been chosen as the first civilian to travel to space, was highly anticipated. NASA had grand plans to expand the reach of the teacher in space program, in addition to continuing to demonstrate the success of the Space Shuttle. With Challenger, NASA not only wanted to demonstrate that its Space Shuttle program was safe and efficient, but also to draw public attention to the importance of education and scientific exploration. This high-pressure environment, focused on visible and successful results, was one of the main contributing factors to the tragedy. The concept of safety was progressively eclipsed by this need to prove to the world that NASA was on a successful trajectory. At its core, there was an institutional mentality that the mission needed to go ahead no matter what. NASA management and executives were more concerned with meeting the schedule than with adequately assessing conditions that could endanger the lives of astronauts. Within this institutional pressure, a culture of conformity prevailed. NASA's leadership model operated with a very rigid hierarchy, where decisions were made from the top down. When Morton Thiokol engineers, such as Roger Boysley, identified a significant risk with the O-rings, which were fundamental components of solid-fuel rockets, their concerns were not adequately heeded. Boysley knew that the low temperatures predicted for the launch could compromise the O-rings, making them stiffer and less able to properly seal the joints, which could result in a catastrophic failure. He and his engineering team tried tirelessly to warn their superiors, but the pressure to maintain the schedule and launch Challenger was too intense. The crucial meeting that took place on the eve of the launch, on January 27, 1986, is a clear example of how NASA's corporate culture favored compliance over critical analysis. Morton Thiokol, the company contracted to manufacture the rockets, expressed serious concerns about the safety of the launch due to the low temperatures. The company's engineers, including Boysley, recommended that the launch be postponed until weather conditions improved. However, this recommendation was ignored. NASA executives pressured their superiors at Morton Thiokol to proceed with the launch, despite evidence that safety was being compromised. The pressure of meeting a tight deadline and the feeling that the mission could not be postponed again led to a decision that ultimately proved tragic. In part, this was caused by a we-can't-fail mentality that permeated NASA. The space agency was already grappling with the failure of the Apollo program, which had been terminated and replaced by the Space Shuttle program. The Space Shuttle program had one major goal: to be economical and efficient, allowing for cheaper and more frequent trips to space. The success of Challenger was crucial to the program's continuity, and the idea of imminent failure was simply unthinkable. The failure of Boystrely and other engineers to be heard became a consequence of an institution that was more concerned with public perception than with the actual risks involved. This pressure to meet the schedule was reflected in a critical communication failure. NASA and Morton Thiokol failed to have a decision-making process that prioritized safety and proper technical analysis. Boystrely and his team were unable to convince decision-makers that the O-ring failure, caused by low temperatures, was an unacceptable risk. Instead, the engineers were pressured to yield to the demand to proceed with the mission. This was not a case of a single technical failure, but a failure of judgment at all levels of the organization. NASA's rigid hierarchical structure and its relationship with contractors, such as Morton Thiokol, also played a significant role. Morton Thiokol's engineers were, in essence, subordinate to NASA authorities in terms of final decision-making. Although the company possessed all the technical expertise, the final decision on the launch was made by NASA executives, who were more concerned with the mission's goals and success than with the detailed technical analysis of potential failures. This disconnect between field technicians and decision-makers at higher levels created a system where safety was neglected in favor of schedule adherence. Furthermore, NASA was also under significant political pressure. The space program was at the heart of the Cold War's ideological warfare, and the success of Challenger was seen as a demonstration of U.S. strength and competence. The media also played a significant role, with intense coverage that put NASA under constant pressure to demonstrate that the space program was safe and successful. The presence of Christa McAuliffe aboard the Challenger, who would be the first civilian to travel to space, further increased the pressure for a successful launch. She represented a new phase for space exploration, making it an even more symbolic mission for the United States. The Challenger disaster and the failure of decisions made by NASA and Morton Thiokol show how external pressures and organizational culture can erode the effectiveness of a system that should be focused on safety. The tragedy revealed the lack of an adequate risk assessment process and the failure to listen to the technical experts who were warning about the real dangers. The failure was not only technical, but also institutional and cultural, showing that when institutional pressure and the pursuit of visible results outweigh the needs for a detailed risk and safety assessment, the consequences can be disastrous. Following the disaster, NASA faced a profound reassessment of its organizational culture and internal processes. The accident led to significant changes in how NASA conducted its missions and how engineers and scientists were heard regarding their concerns. But by then, the disaster had occurred and 7 lives were lost due to a system failure that could have been prevented if safety had been treated with the seriousness it deserved from the outset. January 28, 1986, was a day that should have been celebratory for NASA, but ended up becoming one of the greatest tragedies in the history of space exploration. The Challenger, the space shuttle scheduled to launch that day, represented the promise of a new era for NASA and for space exploration in general. This launch, particularly significant due to the presence of Christa McAuliffe, a teacher who will be the first civilian in space, was designed to show the world the accessibility of space and the possibility of carrying civilians into space travel. McAuliffe, who had been selected to participate in the Teacher in Space program, was a symbol of how NASA wanted to bring the public closer to space exploration. Her participation was intended to be an inspiration to millions of young people, especially those interested in science and education. The program was promoted as a way to humanize space, bringing an ordinary person to the mission, making space travel more tangible and accessible to the general population. The launch of Challenger was also a showcase for NASA to demonstrate the success of the Space Shuttle, a project that was proving increasingly vital for the continuation of U.S. space missions. However, Launch Day was marked by a series of critical factors that turned the event into a tragedy. The weather conditions, which would be considered less than ideal for any other mission, were far below expectations for Florida. The Challenger was scheduled to take off in very cold weather, with temperatures reaching -1 degree Celsius, 30 degrees Fahrenheit. These conditions have been anticipated by NASA and Morton Thiokol engineers, the contractor responsible for the solid-fuel rockets, but the warning about the danger posed by the extreme cold was ignored by the institution, and the mission was authorized to proceed. The issue of the O-rings had already been discussed with substantial technical concerns, as the material used to seal the Space Shuttle solid-fuel engines was not capable of functioning properly at low temperatures. This critical rocket component, if it failed, would result in a fuel leak and could lead to a catastrophic structural failure. Despite warnings from engineers like Roger Boisley, who insisted the launch be postponed, pressure to maintain the schedule prevailed, and the launch was authorized. On the morning of the launch, the weather was especially cold. Even with this information, NASA executives were unwilling to cancel the mission. For many at the agency, the Challenger launch represented a continuation of the promise of the Space Shuttle program, and postponing the launch once again would mean losing an important opportunity, both from the point of view of public visibility and technological advancement. Krista McAuliffe, as a symbol of the teacher in space program, was at the center of this event, which also increased expectations surrounding the mission's success. At 11:38 a.m., NASA authorized the launch of Challenger. The atmosphere was thick with anticipation, and the world watched, both on television and live broadcasts, as the Space Shuttle prepared for another trip into space. Solid-fuel rockets were ignited, and the Challenger began its journey. In the first few seconds of flight, everything seemed to be proceeding normally. However, after only 73 seconds of flight, tragedy unfolded. A failure in the O-ring, exacerbated by extremely low temperatures, resulted in a fuel leak from the engine, leading to a cataclysmic explosion. The Challenger disintegrated in midair, and the 7 astronauts on board lost their lives. The impact of the explosion was immediate and devastating, not only for NASA and the United States, but for the entire world. The Challenger, which had been a symbol of progress, now became a symbol of tragedy and institutional failure. The moment of the explosion was broadcast live to millions of viewers. Images of the Space Shuttle disintegrating in midair are etched into the collective memory. Not only were the lives of the astronauts lost, but also the collective dream of a future where space exploration would be carried out safely and efficiently. The death of Krista McAuliffe, a teacher who represented the hope of many, was particularly symbolic. She had been chosen to push the teacher in space program to its limits, but her dream, and that of all who saw her as a heroine, was brutally interrupted. The impact of the Challenger tragedy extended far beyond the borders of the United States. The disaster was broadcast live to millions of people who watched in stunned silence as the Space Shuttle disintegrated in midair. For many, the Challenger explosion was more than an accident. It was a personal loss. The astronauts who lost their lives were admired and respected figures, and their deaths were a profound blow to the collective spirit of exploration and adventure. Following the disaster, the reaction was immediate. NASA underwent a process of reassessing its organizational culture and safety practices. The emotional impact of the tragedy was profound, but the institutional impact was even more significant. The tragedy led to drastic changes in how NASA conducted its missions and how engineers and technicians were consulted on crucial safety decisions. The Challenger not only undermined public trust in NASA, but also called into question the procedures and ethics of decision-making within the agency itself. The impact of the Challenger disaster was so profound that, for many, the tragedy represented not only the loss of 7 human lives, but a crisis of confidence in NASA's capabilities and, by extension, in the United States space program. When the Challenger disintegrated in midair, the nation was swept by a wave of grief and outrage. For NASA, which had been a symbol of innovation and courage since the Apollo 11 days, the accident represented a devastating blow to its credibility and the prestige it had earned over the years. For the general public, it was a personal loss, largely because the lives of the astronauts were so intimately linked to the idea that space was a place of achievement, exploration, and, above all, safety. The shocking national disaster. On the morning of January 28, 1986, millions of Americans were watching the launch live. The launch of Krista McAuliffe, a public school teacher selected to be the first civilian to travel to space, was destined to be an event of great symbolic significance. The Teacher in Space program had been promoted as a way to show that space exploration wasn't reserved only for career astronauts, but also for civilians, including educators. When the tragedy occurred, the entire country was watching live, and this only amplified the emotional impact of the loss. The accident was so sudden and unexpected that many couldn't process it immediately. The Space Shuttle Challenger, soaring on its trajectory into space, disintegrated in an explosion visible to thousands of viewers and broadcast live to millions of homes worldwide. The roar of the explosion echoed in many homes, and while eyes were fixed on the screen, a somber silence fell over the nation. 7 astronauts, including Krista McAuliffe, lost their lives instantly. The first reaction of many was utter disbelief. For those at home, it was unthinkable that something so tragic could happen in the modern age, during a mission that was being observed and celebrated as part of scientific and educational advancement. The shock and personal grief. The impact of Krista McAuliffe's death, in particular, was not only technical or scientific, but personal. She represented the dreams of millions of Americans, especially young students who saw her as a heroine. McAuliffe was not a career astronaut, but a teacher who had been chosen from thousands of candidates to embark on the Challenger mission. Her participation represented the idea that anyone, even an ordinary teacher, could contribute to space exploration, making her a figure of great symbolism and identification for citizens. When the explosion occurred, the nation lost not just a person, but a symbol of hope and possibilities for future generations. The commotion was immediate, and Reagan's words were careful but full of genuine emotion. The president made a statement shortly after the tragedy, calling for unity and strength in the country, but above all, reminding the American people that astronauts were heroes and that their sacrifice would not be in vain. The nation lost 7 heroes today, he said in a speech broadcast nationwide, while the entire world watched in silence. The coverage of the tragedy was one of the most extensive in television history, with news channels broadcasting in real time not only the details of the accident, but also the initial efforts to find answers about the cause of the explosion. The media played a crucial role in amplifying the public shock and grief, but also in bringing the investigation into intense public scrutiny. The coverage was not limited to showing images of the explosion. It also focused on interviews with experts, family members of the victims, and especially engineers and former astronauts. The media coverage generated a national debate about the safety of the space program, communication failures within NASA, and the critical decisions that were made in the weeks leading up to the launch. One of the first questions raised by the media was how such a large tragedy could have occurred in a program that was being considered one of the greatest achievements of modern space technology. The idea that such an advanced system could fail so catastrophically generated public distrust. The public and the media wanted to understand the Challenger's failures, and this led to an intense focus on communication breakdowns within NASA and the misguided decisions that had been made. The media played a vital role in providing a platform for experts and critics from inside and outside NASA, who not only discussed the system's failures, but also began to expose an organizational culture within NASA that prioritized speed of execution and political pressure over technical analysis and safety. NASA's response to this public coverage was also crucial as, during the investigation, many members of the agency found themselves forced to question their own decisions. The national grieving process. Collective grief was one of the most notable aspects of the public reaction to the tragedy. While astronaut deaths were not uncommon, the nature of the disaster, especially the live public exposure of the launch and catastrophic failure, made the loss felt differently. For many people, the Challenger astronauts were not just distant public figures, but almost members of their own families. Many watched the launch with anticipation and hope, and when images of the explosion emerged, it was as if the dreams of an entire generation had been shattered in a matter of seconds. This national grief was further fueled by the death of McAuliffe, who represented the possibility of a bright future full of opportunities for ordinary citizens. Her death caused schools across the country to fall silent, and many young people lost not only the chance to see a heroine in space, but also the symbol that education and hard work could lead them to the unknown. The consequences for NASA. Immediately after the tragedy, NASA faced an avalanche of questions and criticism. The Challenger tragedy was not just a technical failure, but an institutional disaster. The failure to heed safety warnings from engineers like Roger Boysley and the pressure to maintain the mission schedule without adequate risk analysis created an environment where the focus on the mission was placed above safety and ethical responsibility. As a result, NASA faced a public crisis of confidence that lasted for years. The immediate impact was that NASA was forced to completely overhaul its safety policies and internal decision-making culture. For months, the agency was intensely investigated and criticized for its failures. Congressional investigations and the Rogers Commission revealed flaws in NASA's internal communications and its inability to properly assess risks. The decision to proceed with the Challenger launch in the face of warnings was not just a technical failure, but a systemic failure that resulted in the deaths of 7 astronauts. The Challenger tragedy forced NASA to rethink its approach to safety, organizational culture, and the importance of listening to technical professionals. While it led to significant changes in how NASA conducts its processes and missions, the human cost was extremely high. The agency had to rebuild its public image and, over the years, changes in safety culture and communication within NASA have been made to ensure that the disaster would not be repeated. Following the tragic Challenger disaster, an investigation was immediately launched to understand what caused the failure and how it could be prevented in the future. The accident not only destroyed a space shuttle and took the lives of 7 astronauts, but also deeply shook public confidence in NASA and its ability to safely manage such an advanced space program. The investigation was conducted by the Rogers Commission, an independent commission formed by President Ronald Reagan shortly after the accident. The commission was tasked with determining the causes of the disaster, examining technical, organizational, and cultural failures within NASA, and suggesting changes that could prevent something like this from happening again. The Rogers Commission was composed of high-caliber figures, including former United States Secretary of Defense William Rogers and astronaut Neil Armstrong, who became one of the Commission's best-known members. In addition, physicist and Nobel laureate Richard Feynman was invited to join the Commission due to his vast experience in scientific research and his reputation as a tireless questioner of established conventions. The Commission was formed quickly to ensure that NASA was investigated independently and impartially, without the pressure of a possible attempt to cover up internal failures. The Commission's initial objective was to understand the causes of the Challenger disaster, examine the technical failure of the O-rings, and also understand how institutional decisions within NASA allowed the launch to be authorized despite warnings from technicians and engineers, such as Roger Boysley, who had identified potential flaws. The impact of the O-ring failure, which deteriorated due to extreme cold, was evident, but the Commission needed to go further to understand the root causes that led to this technical failure and how the error was ignored. Technical investigation revealed that the primary cause of the accident was a failure in the O-rings, which are crucial components for sealing the joints of the Challenger's solid-fuel rocket engines. The O-rings were designed to ensure that the hot gases produced by the combustion of the fuel did not leak into unwanted areas of the engine. If the O-rings failed, fuel would leak out, causing excessive pressure on the joints and potentially triggering an explosion. The O-rings were particularly sensitive to low temperatures. Launch day, January 28, 1986, was extremely cold, with temperatures around -1 degree Celsius 30 degrees Fahrenheit, well below what NASA and its contractors, such as Morton Thiokol, considered adequate for the safe operation of solid-fuel rockets. The low temperature caused the O-rings to lose their elasticity and fail to provide an effective seal. This caused hot gas to leak from one of the rocket engines, which, within seconds, resulted in the explosion of the Space Shuttle. The Rogers Commission concluded that the O-ring failure was the primary cause of the Challenger explosion, but the investigation also focused on organizational failures and errors of judgment that led to the decision to proceed with the launch despite clear warnings. The Commission was emphatic in stating that the failure was not only technical, but also an institutional failure within NASA and its suppliers. During the investigation, it became clear that the failures were not only technical, but also organizational and cultural. NASA was operating under a culture where institutional deadlines and objectives often overshadowed safety and rigorous risk analysis. The organizational environment within NASA was marked by pressure to meet launch targets and a lack of adequate channels to communicate critical concerns from engineers and technicians. The investigating committee identified a systemic communication failure within NASA. Although engineers like Roger Boysley attempted to warn of the risks, their concerns were not properly heeded by decision-makers. Boysley, in particular, was one of the leading whistleblowers of the institutional negligence that allowed the Challenger launch to proceed. His struggle to be heard in his attempt to prevent the launch, based on concrete technical data, were stifled by pressure to maintain the launch schedule. The fact that the engineers' warnings were ignored and that, even with clear information about the risks, the launch was authorized, pointed to culture compliance within NASA. Technical and safety concerns were being systematically disregarded in favor of an institutional vision that prioritized immediate success and mission continuity. This organizational culture was one of the main flaws that led to the Challenger tragedy. The committee also criticized the lack of an adequate process for technical warnings to be effectively considered within NASA's decision-making framework. During the investigations, the Rogers Commission gathered testimony from a number of key figures within NASA and Morton Thiokol, as well as external experts such as Richard Feynman. Feynman, a key figure in the investigation, was instrumental in highlighting the importance of scientific transparency and healthy skepticism in engineering decisions. Known for his work in physics and his crucial role in the development of quantum physics theory, Feynman used his experience and investigative skills to question the logic behind NASA's decisions and to identify flaws in the agency's safety process. Feynman was celebrated for his investigations and his relentless skepticism in analyzing evidence and technical data. One of the most notable moments of his participation was his detailed analysis of the behavior of O-rings at low temperatures. Feynman demonstrated, during a public hearing, how the O-ring could deteriorate and fail under extreme cold conditions, using a simple experiment with a piece of rubber and a cup of ice. His ability to explain complex technical issues in an accessible way helped highlight the importance of fully understanding the impact of environmental conditions on launch operations and, especially, on the failure of critical components, such as the O-ring. The Rogers Commission's final report pointed to a number of technical and organizational shortcomings, but perhaps the most critical point was its conclusion about NASA's culture. The report identified a failure to prioritize safety and proper risk assessment, placing mission objectives and deadlines ahead of a need to ensure safe launch conditions. Furthermore, the Commission recommended a number of changes to NASA's decision-making process, suggesting that NASA needed to implement a more robust risk assessment system, as well as ensuring that engineers had a stronger voice in safety discussions. NASA accepted the Commission's recommendations, and several important changes were made to the decision-making process and organizational culture. Space Shuttle launches were suspended for more than 2 years while NASA focused on improving its safety systems and internal communication. These changes helped to partially restore public confidence in NASA, but the loss of the Challenger and its astronauts remain an indelible mark on the history of space exploration. The legacy of Roger Boysley and the importance of professional ethics. Following the investigation, Roger Boysley became an advocate for professional ethics and safety in the engineering industries. He continued to speak about the importance of engineers maintaining their ethical values, even in the face of institutional pressures, and about the need to prioritize safety in all engineering decisions. His courage in speaking publicly about the ignored warnings and his persistence in defending the safety of the astronauts aboard the Challenger made him a hero not only within the engineering community, but also in the broader movement for professional ethics. Following the Challenger tragedy, Roger Boysley found himself at the center of a story that was both one of quiet heroism and profound institutional injustice. He was one of the Morton Thiokol engineers who had repeatedly warned about the risks of launching the Challenger. His detailed analysis of the O-ring defects and adverse weather conditions had the effect of a wake-up call. But despite his efforts to prevent the tragedy, his warnings were ignored by NASA authorities and executives at his own company, who, under pressure, relented and allowed the launch. After the explosion, Boysley became one of the leading advocates for safety in engineering projects and professional ethics. But his journey after the disaster was marked by an emotional burden and a personal and professional struggle for justice. The personal and professional impact. After the disaster, Boysley experienced a deep sense of guilt and frustration. Although he had done everything in his power to prevent the disaster, he was deeply affected by the loss of human life. Boysley knew that his concerns had been taken seriously, perhaps the tragedy could have been avoided. This feeling of powerlessness and the emotional responsibility he felt, despite having tried to warn about the risks, were extremely difficult to cope with. Boysterly went through a professional identity crisis. As an engineer, his first responsibility should have been safety, and he believed his superiors hadn't given his concerns the importance they deserved. He knew the system had failed, but he couldn't shake the feeling that, somehow, he had also failed. This guilt was exacerbated by the fact that his fight for justice was initially ignored. His integrity and commitment to professional ethics became his line of defense, but he knew that, to many people within NASA, he was seen as a nuisance. Furthermore, Boysterly suffered professional consequences. Although he tried to protect the lives of the astronauts with his warnings, he soon realized that his reputation was severely damaged within his own company and the industry as a whole. Morton Thiokol, which initially seemed to side with the engineers, eventually distanced itself from Boysterly after the disaster, concerned about the potential legal and financial repercussions of the accident. Boysterly was not rewarded for his efforts in warning about the risk. On the contrary, he faced institutional hostility and a lack of support from his superiors, who not only ignored his concerns but also sought to distance themselves from him after the investigations began. Boysterly as a whistleblower and advocate for ethics. Despite the personal and professional difficulties, Boysterly did not give up. When the Rogers Commission began investigating the causes of the accident, he became one of the main whistleblowers of the Challenger. His statements were crucial for the public and investigators to understand the dynamics of the ignored decisions within NASA and its contractors. Boysterly was incisive and articulate in explaining how his warnings about the O-rings and adverse weather conditions were disregarded, not only due to technical ignorance, but also due to a lack of ethical responsibility within NASA's organizational culture. In his interviews, Boysterly explained in detail the conversations he had with his superiors at Morton Thiokol and NASA. He made it clear that he knew, based on his experience and technical knowledge, that the launch should not have occurred. However, he also acknowledged that the pressure to meet mission deadlines and objectives was so great that the decision to launch Challenger was made without a proper risk assessment. Boysterly categorically stated that the O-ring failure was not the sole cause of the disaster, but that it was compounded by a series of institutional and cultural failures, such as pressure for results and the lack of adequate channels for safety concerns to be heard. Over the years following the tragedy, Boysterly became an advocate for professional ethics in engineering and other high-risk industries. He emphasized in numerous interviews and lectures the need to ensure that technical professionals are heard and that safety issues are always prioritized. Boysterly also worked to demystify the idea that professional ethics could be sacrificed in the name of institutional success. He firmly believed that the gears of a large organization should not function in a way that covers up technical failures, but rather as a control system to ensure the safety and well-being of those involved. The personal price of truth. While Boysterly was applauded by many for his courage and integrity, he also paid a personal price. Support from his colleagues at Morton Thiokol and within NASA was minimal, and he found himself isolated in his struggle. His journey to expose the failures and seek justice was marked by personal and professional difficulties that deeply affected him. Boysterly faced social and professional isolation because, by pointing out the system's failure and the negligence that led to the tragedy, he became a figure seen by many as a traitor to the company, even though he was acting in defense of public safety and ethical principles. The pressure to remain silent was intense, but Boysterly did not stay quiet. He knew that his fight was not just about saving his career or his reputation, but about defending human lives and preserving the values of responsible engineering. His decision to speak out, to expose himself to risk, and to denounce what had happened was an act of honesty and courage, which was not recognized at first. Even after the tragedy, he faced criticism, as many saw his actions as a challenge to NASA's policies and authority. The late recognition. Over time, Boysterly's work began to be more widely recognized. In a belated move, Roger Boysterly came to be regarded as a figure of ethical integration in engineering and other high-risk fields. He not only called for change at NASA, but also made history by showing the world that commitment to ethics is essential, even in situations where there is great organizational pressure. In interviews and speeches, Boysterly stressed that morality and safety should not be sacrificed for any other objective. His story became a wake-up call not only for NASA, but for all large organizations that deal with high risks, such as engineering and construction companies, and even the aviation industry. Roger Boisley continued to lecture, write, and speak about the importance of an organizational culture that prioritizes safety and professional ethics above external pressures and institutional interests. In many of his accounts, he emphasized the need to educate engineers and technicians so that they never allow their voice to be silenced when safety is at risk. Boisley, with his experience, became a true moral voice in engineering, ultimately being recognized for his courage and persistence. The enduring legacy of Boisley. Roger Boisley's legacy extended far beyond the Challenger disaster. His story of resilience and courage helped establish new benchmarks for safety and professional ethics in many industries. Today, Boisley is remembered as an example of integrity and responsibility. Her work helped transform how organizations address safety concerns, and her personal journey is a powerful reminder that, however difficult it may be, there's always immense value in standing up for truth and the safety of human lives. The Challenger tragedy, which occurred on January 28, 1986, remains one of the most significant and painful events in the history of space exploration. The explosion that took the lives of 7 astronauts, including Professor Krista McAuliffe, marked not only the end of a mission but the beginning of a new era of reflection on safety, ethics, and organizational culture within NASA and the entire aerospace community. The disaster was not just a technical failure, but the result of a chain of human and institutional decisions that prioritize goals and timelines over prudence and safety. The lessons learned from Challenger have become fundamental to the future of space exploration, serving as a constant reminder that scientific progress without responsibility can have an unbearable cost. NASA's deep reassessment. Following the disaster, NASA underwent one of the most profound restructurings in its history. The impact of Challenger was so devastating that it led to a complete suspension of Space Shuttle launches for more than 2 years. The agency was forced to rethink its safety practices, its technical protocols, and, above all, its organizational culture. The Rogers Commission, formed to investigate the accident, revealed not only technical flaws, such as the vulnerability of O-rings under low temperatures, but also profound failures in internal communication and decision-making. The investigation showed that engineers had warned of the danger, but their voices were silenced by a culture of compliance and the pressure to maintain the launch schedule. These revelations were a hard blow for NASA, which until then had been seen as the pinnacle of technical excellence and scientific organization. The agency's image as a symbol of technological infallibility was shaken, and the public trust that had been earned during the Apollo missions was drastically compromised. Faced with this, NASA had to confront a harsh reality. It had become an organization that, at some point, placed more emphasis on showing results than on ensuring that those results were achieved safely. To address this crisis, NASA adopted a series of measures aimed at correcting the flaws identified by the Rogers Commission. Among these was the creation of new communication channels within the agency's hierarchical structure, ensuring that engineers and technicians could directly communicate their safety concerns without fear of reprisal. In addition, the agency introduced an independent safety office, whose mission was to review and audit launch decisions, especially regarding environmental conditions and technical failures. This change represented an important step in rebuilding public and employee confidence in NASA's integrity. Lessons on organizational culture. The Challenger tragedy also left a valuable lesson about the danger of a culture of silence within institutions. The disaster showed that, in complex systems, decisions cannot be guided solely by goals and external pressures, but must be based on rigorous technical assessment and an unwavering commitment to safety. The culture that prevailed at NASA before the Challenger was characterized by an excessive belief in its own competence and a reluctance to admit vulnerabilities. Political and public pressure to keep the Space Shuttle program active led to hasty decisions, ignoring clear warning signs. This combination of institutional pressure, technical pride, and lack of internal communication proved fatal. After the accident, several universities and institutions began studying the Challenger case as an example of organizational failure. The disaster became a classic case study on the importance of internal communication, safety culture, and ethics in corporate decision-making. In management and engineering programs around the world, The case began to be used to teach about the consequences of a culture where the fear of questioning superior decisions can lead to catastrophe. The lesson was clear. Technical competence is not enough if there is no environment where the truth can be told without fear. Technical and procedural changes. In addition to organizational changes, NASA also implemented a series of technical reforms after the disaster. The design of the solid-fuel rockets was completely revised. The O-rings, whose failure was a direct cause of the explosion, were redesigned to ensure greater strength and elasticity in extreme cold conditions. New materials were tested and implemented, and rigorous inspection procedures were created to ensure that all critical components underwent reviews before each launch. Another major change was the adoption of a more decentralized decision-making process, in which engineers gained more autonomy to halt or postpone launches if they identified safety risks. This change was a direct response to the problem Roger Boysley and his colleagues faced when they tried to alert NASA to the risks of the Challenger launch. Now, the agency was trying to create an environment where safety was the absolute priority, regardless of political pressure or schedule. The impact on the space program. The impact of Challenger was felt throughout the United States scientific and space community. The Space Shuttle program, which had been conceived as a future of space exploration, came under greater skepticism. The dream of transforming space shuttles into routine transport vehicles for space was severely damaged. The perception that space had become routine was replaced by a new awareness of the extreme risks involved in each mission. NASA went more than 2 years without conducting any launches. The next flight would only occur in 1988, with the Space Shuttle Discovery, in a mission that symbolized a rebirth of confidence. But even with the return of missions, the ghost of Challenger never completely disappeared. Each launch was now surrounded by caution and a silent reverence for the lives lost on that cold January day. The influence on global security policies. The disaster also influenced other industries outside the space field. Airlines, technology manufacturers, and government organizations began to review their safety protocols and internal communication structures. The Challenger incident became a reminder that human and cultural failures can be as lethal as technical failures. In the corporate world, the concept of safety culture became a recurring theme, and business leaders began to understand that transparency and actively listening to technical experts were vital to the sustainable success of any undertaking. The human and ethical legacy. Perhaps the greatest legacy of the Challenger disaster was a recognition of the importance of professional ethics. The figure of Roger Boysley emerged as a symbol of the moral integrity that was lacking in NASA's decisions. Boysley, who had tried to prevent the tragedy, came to be seen as an example that, even amidst institutional pressure, it is possible and necessary to defend what is right. His story began to be studied in engineering, business, and ethics colleges around the world as an example of moral courage in the face of institutional complacency. The Challenger tragedy reminded the world that technological progress must always go hand in hand with ethical responsibility. The pursuit of innovation cannot overshadow the commitment to human life. The cost of institutional negligence and the pressure for quick results was a loss of 7 precious lives and a permanent scar on the history of space exploration. Final reflection, a new standard of consciousness. The lessons left by the Challenger transformed not only NASA, but also the way the world views risk, responsibility, and ethics. The disaster forced a collective reassessment of how humanity should balance its ambition to explore the unknown with the moral obligation to protect life. The Challenger's legacy is twofold. It is a warning about the danger of negligence and, at the same time, a tribute to the courage of those who dared to question and fight for a safer and more humane system. The Challenger tragedy was not merely a catastrophic technical accident, but a transformative event that exposed deep flaws in how one of the world's largest agencies, NASA, handles safety and ethical responsibility. What could be described as a failure in technical components, the O-rings, revealed an even deeper flaw in NASA's organizational culture and decision-making processes. But the disaster was also a human tragedy, with the deaths of 7 astronauts, including Krista McAuliffe, a teacher who represented the future of education and space exploration. While the accident has been widely attributed to technical and cultural failures, one person played a pivotal role in trying to avert the tragedy. Roger Boysley, the engineer who identified the risks, became the epicenter of the fight for ethics and safety. Boysterly's integrity. Roger Boysterly, like many engineers of the position, was aware of the technical complexities and risks involved in space missions. When he and his colleagues at Morton Thiokol warned about the potential failure of the O-rings under the extreme cold conditions, they weren't just raising technical concerns. Boysterly knew, based on his experience and understanding of the system, that there were no guarantees a launch would be safe. The exceptionally low temperature was a deciding factor, and the O-rings, critical components of the solid-fuel rocket, could malfunction, resulting in a gas leak and eventually catastrophic structural failure. Boysterly wasn't just being technical, he was being ethical. He knew that if the launch were authorized, it could mean the death of astronauts. His struggle to convince his superiors to postpone the launch was a demonstration of moral and professional courage. He was concerned not only about the well-being of the astronauts, but also about the impact an error in judgment could have on space exploration as a whole. His determination to warn about the risks, even as pressure from NASA and Morton Thiokol intensified, was a rare example of professional integrity, institutional failure, and the disregard for warnings. The Challenger tragedy can be seen, in part, as a product of organizational failure, and this failure was deeply rooted in the corporate culture of NASA and its contractors. The pressure to maintain the launch schedule, the desire to avoid delays, and the fear of losing public support were factors that obscured technical concerns. NASA, an internationally prestigious agency, was so focused on showing quick and visible results that it neglected the warnings given by Boysterly and other engineers. They were not heard, and concerns were systematically minimized. The culture within NASA and Morton Thiokol seemed to lack a robust internal communication system. When Boysterly raised the warnings about the imminent risk, he found himself battling a system that prioritized public perfection over actual safety. The decision-making system was not prepared to listen to critical voices, especially those coming from engineers like Boysterly, who were uncomfortable putting astronauts at risk. Hierarchy and pressure to proceed with the launch ultimately prevailed over technical sound judgment. It was this organizational failure that led to the Challenger explosion, a failure that could have been avoided if the system had given more weight to internal warnings. Roger Boysterly's legacy and lessons learned. Roger Boysterly was not only one of the key whistleblowers of the accident, but he became a symbol of ethical resistance in the field of engineering. His legacy goes far beyond his fight to prevent the disaster. He became an advocate for professional accountability and safety, and his courage in exposing the failings of NASA and his contractors helped change how organizations approach safety and ethics issues in the workplace. Boysterly taught the world that, in high-responsibility sectors like aerospace engineering, ethics cannot be neglected in the name of quick results or institutional pressure. After the accident, Boysterly dedicated himself to disseminating the lessons learned and the importance of a culture of safety and accountability within engineering organizations. He began speaking publicly about the failures that had occurred and the need to ensure that all professionals, regardless of their hierarchical position, had a voice when it came to reporting risks. His actions became a landmark in the fight for transparency and ethical accountability in high-risk sectors. Boysterly's courage not only helped expose the flaws that led to the tragedy, but also caused the engineering industry and NASA to rethink the importance of communication and safety-based decision-making, rather than external pressures to meet targets and deadlines. His struggle has become a lasting legacy that continues to influence future generations of engineers and leaders of high-risk organizations. The post-Challenger cultural and institutional impact, beyond the cultural changes within NASA and the aerospace industry. The disaster also generated global reflection on how institutions deal with pressure and risk. The Challenger accident helped raise global awareness of the importance of creating an organizational culture where safety and ethical concerns are not ignored, even when these concerns contradict institutional priorities. Following the Challenger disaster, many companies and organizations began to reassess how their hierarchical and cultural structures could impact the safety and well-being of the people who worked for them. The accident also contributed to a shift in mindset in high-risk industries, such as aviation, where safety became an absolute priority. The Challenger disaster revealed that, when it comes to safety failures, prevention is always better than correction. Roger Boysterly became a benchmark regarding the importance of listening to technical voices, something that should not be neglected, regardless of the pressure to advance projects and objectives. The importance of professional ethics and responsibility. The lasting impact of the Challenger is also a warning to all professionals in technical and scientific fields. Roger Boisterly's story is a reminder that professional ethics should be the basis of all decisions, especially in fields where human life is at stake. Boisterly not only raised concerns about a technical component, but also made an appeal to all professionals to never compromise safety and integrity in their careers in the name of rushed results or institutional goals. His story reflects the importance of having an uncompromising ethical stance, regardless of the personal and professional difficulties this may cause. Boisterly knew that his fight for safety was not just a matter of career, but of human lives. He demonstrated that an ethical professional must have the courage to speak the truth, even when that truth is uncomfortable or unpopular. Conclusion: heroism amidst tragedy. In the end, the Challenger disaster was a product of a series of failures, but at the same time, it became a powerful lesson about the importance of ethics, responsibility, and organizational culture. Roger Boisterly, though initially ignored, became a silent hero, someone who struggled to warn of risks and prevent tragedy did not go unnoticed in the long run. He became a symbol of the fight for professional ethics and responsibility in all technical professions. The Challenger tragedy teaches us that, regardless of how advanced the technology, human responsibility is always the most crucial component in any mission. Roger Boisterly, with his moral and technical warning, left a legacy that goes beyond the Challenger, and his fight for safety and ethics continues to influence the space industry and other high-risk industries to this day.